I want to get this negative 3 because we know we can figure out when it's greater than or less than with 0. And this isn't 0. So we get rid of the negative 3. I'm going to add 3 to both sides. We end up with 10z 29 over negative 9z minus 72. Adding 3 to both sides, so plus 3. That's 3 over 1. To get a common denominator, I'm going to multiply this denominator by negative 9z minus 72. If I multiply the bottom by that, I have to multiply the top by that. On the bottom, I have a common denominator. I can write the whole thing over a common denominator. But on the top, I end up with 10z plus 29 minus 27z. 3 times negative 72 is 216 minus 72. 3, and if I multiply those, negative 216. If you're doing that mentally, is 3 times 70. 3 times 7 is 21. 3 times 70 is 210. 3 times 2 is 6. Add them together. 216. And that's all over the common denominator, negative 9z is greater than 0. Negative 9z minus 72 is greater than 0. We have to simplify. Negative 27z plus 10 is negative 17z. 29 take away 216, negative 187, all over negative 9z minus 72. And all this is greater than or equal to 0. So I'm going to set the top to be equal to 0, negative 17z minus 187, and we set the top equal to 0. Then I'm going to add 187 to both sides, so I have negative 17z is equal to positive 187. I'm going to divide both sides by negative 17, and that gives me z is equal to negative 11. 187 divided by 17, negative 11. A positive divided by negative is negative. Z is negative 11. Then if we look at the bottom, I have negative 9z minus 72 is equal to 0. Add 72 to both sides. I have negative 9z is equal to 72. Then divide both sides by negative 9 is equal to negative 8. We're looking at a number line with a negative 8 and a negative 11 on it. Something like this. Instead of saying numbers that are less than negative 11, I'm going to pick a number that's less than negative 11. It's a little bit easier, like negative 12. And then equal to negative 11, I'm going to pick negative 11. And then between negative 11 and negative 8, I don't know, negative 10. Then equal to negative 8 is negative 8. And then I'm going to pick a number that's bigger than negative 8, like 0. I'm looking at the top, which is negative 17z minus 187 minus 17z. Like, don't go back to the original top, right? We're looking at the top when it's greater than 0. Negative 17z minus 187. And right down here, I'm going to write that as a formula is equal to negative 17 times the z minus 187, and then I just fill that down. Really, I'm getting positive, 0, negative, negative, negative. And that's really what we're looking for. Ignore that it's 17. Keep in mind, this is positive, 0, negative, negative, negative. And do the same thing for the bottom, which is negative 9z minus 72 is equal to negative 9 times negative 12 minus 72. And then I fill that down and does the same calculation for the negative 12, the negative 11, negative 10, negative 8, and 0. I want to know what negative 17z minus 187 divided by negative 9z minus 72 is. I'm just going to divide these. That divided by that is going to give me a little mini sample at all these different spots. I'm just interested in, is this positive? It's positive here. And we're after, when is it greater than 0? When is it strictly positive? I've got two answers here. It's positive here. At negative 11, it's 0. 0. Between negative 11 and negative 8, it gives us a negative here. At negative 8, we get negative infinity, which is really undefined. Greater than negative 8, we got a positive. And that's what we're looking for. We're looking for when is it greater than 0? When is it positive? It's between z is a member of negative infinity to negative 11, not including the negative 11. Negative infinity to negative 11, not including the negative 11, union from negative 8, but not including the negative 8. So rejecto on the negative 8 all the way to infinity, and rejecto on the infinity. Okay, so doing it this way, just on using the spreadsheet, just a whole lot faster.